Now, if we take example of propanol, 1-propanol and glycerol, both of them are 3 carbon molecules, 1 2 3 1 2 3 3 carbon molecule, but here it has got only one hydroxy, which is hydrophilic, whereas here the molecule has 3 hydroxys. So this obviously we expect it to be more hydrophilic than propanol. Alright. Now just to understand this, we have got to understand a bit of a scale which is HLB scale, hydrophilic lyophilic balance scale. We have seen pH scale, right, which is from 0 to 14. More you tend to move towards 0, the more acidic is the molecule, whereas more you move towards 14, more basic is the molecule. Whereas in case of HLB, what happens is HLB also has scale from 0 to 20. Mind you, this is all you are supposed to know in your course. Okay, for competitive exams, these are all very much essential for you all to know, understand and apply. Alright, okay. So see, I have jotted down certain examples over here. I've jotted down certain examples over here. Now this is the scale. Now 20 means it's totally soluble in water. The molecule is totally soluble in water. And if it comes to 0, it is 0% soluble in water. Alright. Okay. So let's begin with. Now I have, just for simplicity, what I have done is I have taken example of monool. Alright. Propanol, butanol, pentanol, hexanol. 1 propanol, 1 butanol, 1 pentanol, 1 hexanol. And I've given you their HLB values. Now if you check out the HLB values, we'll find that it would keep on decreasing. So I told you this is highly hydrophilic and this is highly lipophilic. So we find as the chain keeps on increasing, the lipophilicity keeps on increasing in a molecule. Alright, so see, chain, big chain, 6 carbon chain, 5 carbon chain, 4 carbon chain, 3 carbon chain. So when we move in from 3 carbon to 6 carbon chain, HLB moves towards lipophilicity. Alright, concept clear? Now what I have done is same thing. I have taken 4 carbon, 5 carbon, 4 carbon, 3 carbon, 2 carbon, and then let's check out for this first. So 4 carbon, we had seen butanol was 7, but when with 4 carbon it is a diol, 2 hydroxy, 2 hydrophilic. Here it had only 1 hydrophilic part, hydroxy. Here it has 2 hydrophilic parts. So butane 1-ol had 7 HLB, whereas butane diol has 8.9. that is, it is those many times or those many percent. If you see, basically, you know, like if you just multiply it with 5, you get the percentage solubility in water. So 8.9 is the HLB, whereas here it was just 7. Then again, when we go to 3 carbon and 2 hydroxy, it rises from 7.48 to 9.38. So now it is more water soluble. So these are more water soluble, these are more oil soluble. Alright. Then if we talk in terms of ethane diol, it is 9.85, 2 carbon and 2 hydroxy. So percentage of hydroxy is very high in the molecule. Alright, much higher than this. So its solubility is also more in water. Then if we take, so its solubility is more in water. Then if we take glycerol, in case of glycerol there are 3 hydroxys. So again the percentage of hydroxy increases in the molecules. It is 11.25 now. And sorbitol, which has got 6 carbon with 6 hydroxy, the HLB is 15.55, too high. I hope this gives you an idea about how with chain and with hydroxy HLB, it becomes, the molecule gets more hydrophilic, and with increase in carbon chain, the lipophilicity is increased.